The question talks about describe the time course between the intravenous and the general anesthetic to the loss of consciousness and explain the delay in the pharmacokinetic principles. So the way you can tackle this question, I found the best way is you talk about the how the drug enters the compartment and then the the plasma effect site across the blood-brain barrier, and then the diffusion across the blood-brain barrier where you talk about effect site and PD, and then you talk about metabolism. So the time to loss of consciousness, so basically the CP50 is about 2.5 mics per mil. After the IV injection, what happens? The drug enters the central compartment and it goes to the vein, to the heart, then to the brain. And then the plasma effect site, which is the brain, the concentration gradient, and then diffusion across the concentration gradient, which is the KEO, right? Because that's the equilibration rate constant. And then you talk about the simultaneous effect of the redistribution and elimination or metabolism. So the drug central compartment, so if you inject closer to the heart, then you're going to have a quicker onset. So loss of consciousness, reduce the distance, also the speed of injection if you inject quick, and obviously if you increase the dose. So that makes sense. And then when the plasma effect site concentration gradient, that's about Fick's law. So then you talk about increased concentration gradient, increased rate of diffusion, increased rate of onset, increased concentration. If you increase the drug dose, if you decrease cardiac output, you actually increase peak plasma, but you slower the time to peak effect. That means you reduce the VD of the central compartment, decrease protein binding, then you increase free drug concentration. Drug diffuses across the blood-brain barrier. KEO, you define them, which is the equilibration rate constant between the plasma and the effect site. Then reflex elimination and uptake by the effect site. T half KO is ln 2 over KO. Increasing KO decreases T half KO. Increases rate of onset quicker. T half KO is the time taken for the effect site concentration to reach 50% of the plasma. For constant infusion, you have 3 to 5 T half KO for the effect site to equilibrate with the plasma concentration. KEO is proportional to membrane over molecular weight times area of thickness. Increase KEO if increased lipid solubility. Increase unionized fraction. Decrease molecular weight. Increase permeability of blood-brain barrier. And then the pharmacodynamic factors. Drug sensitivity, example elderly, are more sensitive to anesthetic agents. Lower CP for loss of consciousness. Drug interactions such as opioids and propofol. Receptor numbers, regulation, example tolerance. And then briefly talk about elderly have a reduced total body weight, reduced CO, and increased sensitivity. So the loss of consciousness, they're more likely to get it. And then you draw the graph and make 2.5, and that's the effect site, and that's the plasma. That's the time to peak effect, and that's the time to loss of consciousness. Importantly, that the time to peak effect depends on the KEO and the PK, but it doesn't affect on the dose. But the time to loss of consciousness depends on the dose and the KEO. So you can remember it. Think of this, right, is a box. We're gonna talking about the loss of consciousness. Obviously CP, that's just a number you have to remember, and you remember from the diagram. But what you're going to do is you're going to inject in the compartment. So you talk about how fast the injection. Then you talk about the diffusion from here to the blood-brain barrier. So this is the effect site, right? So the diffusion here. It's technically K1E, but and then you're going to talk about which is fixed, right? Then you talk about that going into the blood-brain barrier, which is mainly the KEO, because it's the equilibration constant, right, which is negligible. And the KEO is based on PK factors, which is lipid solubility, ionization, and protein binding. And then you talk about PD factors, which is the elderly, the sensitivity, and that kind of stuff, right? So that's pretty much all you have to do. and then you draw the diagram. So it's a difficult question, but if you split it like that, talk about you inject it into the plasma, so you talk about the drugs in the central compartment. Then you talk about so that's just speeding, the speed of onset, the dose, and all that stuff. Then you talk about the plasma effect site, which is fixed. And then you talk about in that, which is also fixed in the effect site, or the distribution across the blood-brain barrier, but the main important thing is the KO, because that's the equilibration between the plasma and the effect site. And then you talk about the PK factors, which is dependent on the KO, which is proportional again to fix. So you're mentioning fix twice. And then you talk about the PD factors and then the graph.